Hello everyone. So recently I came across this problem here, which inspired me to spend way too long writing down a completely useless and ridiculously long formula for multiplying two numbers together. And it looks like this. So what's interesting about this formula is that it is entirely in terms of this one single operation, which I am denoting star. And we're going to figure out what this operation actually is later on in the video. But what's interesting about this operation is that you can use this single operation to add numbers, subtract numbers, divide numbers, and multiply numbers. So this single operation gives you all of those other operations. Some of the formulas don't look pretty, as you can see here, but that's kind of part of the fun. So I want to work through this problem here, and we're going to figure out what this operation is and where this formula is coming from. So the problem comes in two parts. First, we're going to work on this part. Derive the operations addition, subtraction, multiplication, and division from subtraction and reciprocal. And then after we do that, we will use our work to solve the second part. Invent a single binary operation from which addition, subtraction, multiplication, and division can be derived. Okay, so to clarify the first part of this question, you can think of it like this. Let's say that we are given any two real numbers, which I'll call x and y. We have the operations subtraction and reciprocal. So I can calculate 1 over x, I can calculate 1 over y, I can calculate x minus y. And again, this is for any two real numbers. I'm not picking a particular x and y here. It's just for all real numbers. And what the first part of this question is asking us is, can we use this information to figure out what is x plus y, x minus y, x times y, and x divided by y? Well, for subtraction, we're already given this. So we already know how to find x minus y for any two real numbers. So that's just done. The other operations are going to take a little bit of work, and if you want to try that out before we jump into it, go ahead and pause here. Okay, so it turns out that addition is not too much harder than subtraction because it's just the opposite of subtraction. So to do x plus y, we just have to do x minus negative y. X minus negative y, but negative y is just 0 minus y. And so we are done with addition now as well. Here's how we can represent it using only subtraction. And then as I was solving this, I thought that probably division would be the simplest one to move on to next because we have reciprocals. So then how hard could it be to do x divided by y, for example? Well, I kind of got stuck going just this direction using only reciprocals and subtraction. But what I did end up with is, well, x divided by y is x times 1 over y. This is reciprocal, so that's fine. But we do need, for this representation, we need to know how to do multiplication still. So really, the question comes down to, how do we do multiplication? Using only reciprocals and subtraction. If we can figure out how to do multiplication, then we will have division and we will have solved the problem. Now, this turns out to be quite complicated unless you just happen to see the proper tricks. So if you want to give this a try again, I'll give two hints that were very helpful to me as I was trying to solve this problem. The first hint is, before just trying to do general multiplication of x times y, first try and figure out how to square things. And there is a way to figure out how to do x times y in general if you know how to square things. And then hint 2 pertains to actually figuring out how to square things. So in order to figure out how to square things, think along the lines of partial fractions. Partial fraction decomposition. Those are quite vague hints, I know, but if you want to give it a shot again, go ahead and try it out. Okay, so let's figure out how to do multiplication. So the first hint I gave is to first try to figure out how to square things. And the reason for that is, well, if I have two real numbers, x plus y, if I square them, if I multiply this out, then this is equal to x squared plus 2xy plus y squared. And notice we do actually have the product x times y hidden in here, and every other term is a squared term. So I can rearrange this, and I get 2xy is equal to x plus y squared minus x squared minus y squared. So we already know how to add two real numbers. If we can also square real numbers, then we can use this formula to figure out what 2 times x times y is. And then the last step is we just have to figure out how do we divide by 2 so that we can get xy by itself. Dividing by 2 is easier, so I'll go ahead and start with that. So how do we divide by 2? Well, we have subtraction and reciprocals. Thinking along the line of taking reciprocals, x divided by 2 is the same thing as 1 over 2 divided by x, and this is just 1 over 1 over x plus 1 over x. And again, we know how to add in terms of subtraction, so this is a perfectly valid formula for our case. Now, what about squaring? Okay, so for this, I gave the hint to look at partial fraction decomposition. So this is going to seem out of nowhere at first, but I think it will make sense once we sort of explain where it's coming from. So I'm going to start with this expression here, 1 divided by x times x plus 1. If I wanted to break this up using partial fractions, I would want to rewrite this in the form a over x plus b over x plus 1. And if you go through and you do your partial fractions, you will find that a is equal to 1 and b is equal to -1. So I will just go ahead and write that like this. If you're not familiar with partial fractions, you can look that up. There's a bunch of guides on how to do that. But the important thing is this expression is equal to this expression. And why does this help us? Well, if I multiply out the bottom here, I have 1 over x squared plus x. And then over here, I have 1 over x minus 1 over x plus 1. And here you start to see why this is such a neat way to go about this, because we have a squared down here in the denominator, and everything else here is in terms of reciprocals and linear factors. So I can rearrange this for x squared and everything is going to work out. So what I get, if I just take reciprocals of both sides, I have x squared plus x is equal to 1 divided by all of this stuff, 1 over x minus 1 over x plus 1. And then I just have to subtract x. So let me make sure that I'm not running out of room here on my screen. So then I just have to subtract x on both sides. I get x squared is equal to 1 divided by 1 over x minus 1 over x plus 1 minus x. And so we have now our expression for squaring. And I'll admit, this is really sort of an ingenious trick here. It kind of comes out of nowhere. I did not think of this until I read a hint that really pushed me towards thinking about partial fractions. Okay, so now let's recap because we've actually solved the first part of this problem. Let's remember what it was that we were doing. So again, we're trying to derive all of these operations just from subtraction and reciprocal. And we've already figured out how to do addition in terms of subtraction. And we know that we'll also be able to do division if we can just figure out how to do multiplication. So that is what we were doing down here, trying to figure out how to do multiplication. And we're going to do this in 2 steps by figuring out how to square things and figuring out how to divide by 2. Here's our formula for squaring things. Again, this is all in terms of subtraction and reciprocals. Here's our formula for dividing by 2, all in terms of subtraction and reciprocals. And you do see addition showing up here, but again, remember, we already know how to do addition in terms of subtraction. So using these formulas here, we can figure out what the product of x and y is by using this formula, all in terms of subtraction and reciprocals. Let's do a quick example of how that might look. So let's just say that x is equal to 3 and y is equal to 5. So we want to plug in 3 and 5 here and calculate 3 times 5. So just plugging into this formula, I have on the left 2 times 3 times 5 is equal to 3 plus 5. And again, I know how to do 3 plus 5. It's just this formula here. So 3 minus 0 minus 5. So that's all in terms of subtraction. And what we're going to get there is just 8 squared. And then this is minus 3 squared minus 5 squared. Okay, now let's work on the right-hand side. Let's say I want to calculate 8 squared. I have a formula for doing that here. 8 squared is 1 divided by 1 over 8 minus 1 over 9 minus 8. If you get a common denominator and combine these, you'll find that 1/8 minus 1/9 is 1 over 72. So 1 divided by 1 over 72 is 72. So this whole bit here is 72. And then we have the minus 8. And then so we get 72 minus 8 is 64. And we'll do the same thing for 3 squared and 5 squared. So we are able to figure out the entire right-hand side just using subtraction and reciprocals. So we get 64 minus 9 minus 25. Over here we still have this. So we get 2 times 3 times 5 is equal to 30. And then finally, we just have to divide 30 by 2, and we will have 3 times 5. How will we divide 30 by 2? Well, we will use this formula here. So it's 1 divided by 1 over 30 plus 1 over 30. Again, I know how to add using the subtraction formula up above, and this is going to turn into 1 divided by 2 over 30, which is equal to 30 over 2, as we knew it should be, which is 15. And so obviously that is an extremely roundabout way of calculating this result, but the important thing is we have done this entirely using subtraction and reciprocals. So that is it for the first part. Now on to the second part, which is going to give us this binary operation I was talking about in the beginning, which I'm calling star. So we want to invent now a single binary operation that we can get all of our operations from. Okay, so building off the work that we've already done, we know if we can find a single operation that will give us subtraction and reciprocal, then we'll be done. So looking back at the previous work, I notice a lot of things that are like 1 divided by something plus something, or 1 divided by something minus something. Now, I want to be able to get subtraction from this, so I don't think 1 divided by something plus something will work, but maybe something that looks like this. 1 divided by something minus something. So my first thought was, let's say our binary operation is called star, and let's say that x star y is just 1 divided by x minus y. This was kind of my first guess. It seemed natural, and it ends up working. So we just need to check that we can get the reciprocal operation from this and that we can get subtraction. And reciprocal is not hard because if I just make y 0 here, I just get 1 over x. So that means that 1 over x, or reciprocal, is just x star 0. Subtraction is a little bit trickier, but not too bad. So for x minus y, I just have to extract it out of the denominator here. So x minus y I know is 1 divided by 1 over x minus y. And this is just x star y. So x minus y is 1 over x star y. But this is just the reciprocal of x star y, and I know if I do something star 0, I get its reciprocal. So this is equal to x star y star 0. So what I get then is a way to derive the reciprocal operation as well as a way to derive the subtraction operation. And there it is. We know that from these operations, we can get all 4 addition, subtraction, multiplication, and division. So that means now using these formulas, we can get all of those operations just from this star operation. And honestly, that should be the end of it. We have now answered the question satisfactorily, but I really just wanted to see what the multiplication would look like if you actually wrote it out using this operation. So essentially what I had to do was take these formulas and go and rewrite this formula in terms of star, rewrite this formula in terms of star, and then plug everything into this formula. Again, it's going to all be in terms of star, and what you end up getting is that crazy result that I showed you in the beginning. Here it is again one more time if you want to see it, and if you're crazy, maybe try to multiply 2 numbers together using this and let me know if it works out for you. I did do this once. I used it to multiply 3 times 5 to verify that everything was correct, and so long as I didn't make any mistakes or typos, I think that it works out, but I will not be trying it again because it is ridiculous.